Okay. So now we are going to study about the enthalpy change. And what is the meaning of the enthalpy change? So whenever your heat is absorbed or released, when anything is going to happen, the amount of heat energy absorbed in a chemical reaction, it can be formation, it can be neutralization, it can be ionization, it can be hydration, right? It can be anything, hydrogenation as well. So different type of the energies can have different type of the situation. So firstly, I'm just telling you the enthalpy of combustion. So Vishnu, combustion means burning. So can we say burning means carbon plus O2, it will form the CO2.
Yeah.
So it is a combustion of carbon. So do you know coal? So when you
Yeah.
are when you are heating it up, okay, so it means it is taking oxygen, and when it is taking oxygen, so carbon plus O2, it will form carbon dioxide. So this
Yeah.
is your enthalpy of combustion. So we can have so many type of enthalpies. So energy usually change. Just tell me, Vishnu, if you have energy 100, but you are going for a race, okay, like race is going to be announced here or organized here, so you are running, so after the race, after that particular event, so your energy will be low or very high?
Lower.
Lower. So it means there is a change in energy now when something happened. Same thing is happening here, where when this combustion is happening, formation is happening, neutralization is happening, hydration is happening, or hydrogenation is happening. So obviously energy will change. Okay, so we can say it is the heat change. It is the heat change. Usually evolved की हम बात करते हैं. Usually evolved. Mostly time it is evolved. Okay, but it can be absorbed as well. Okay, when one mole of when one mole of substance when one mole of substances are completely burned, one mole of substance, remember we have to take a standard condition, okay, that one mole. So when mole of substance is completely burnt in the oxygen, because because a combustion will take place only, usually take place in the presence of oxygen only, completely burnt in oxygen.
Enthalpy.
So we can say carbon is sulfur. I mean carbon, this is a solid state. Oxygen, this is a gaseous state. So carbon plus O2, it will give you CO2. This is the gases, okay? So delta H is here minus 393.5 kilojoule per mole. Okay, so delta H is minus 393.5. So you have to remember, for the formation of carbon dioxide, we have the delta H 393.5 kilojoule per mole. What is the meaning of that negative sign? That negative sign is heat energy is releasing. Energy is coming outside. It is a exothermic reaction. Okay, heat energy is coming outside. Fine, Vishnu.
Mm-hmm.
So this is the combustion, because combustion is going on. Carbon is combining with the oxygen, it is a combustion. Okay, now, so we can have the yes, so whatever the name it is, so obviously it is doing the same function. Jaisa naam vaisa kaam. In Hindi there is a thing, jaisa kaam vaisa naam. Do you know what is the meaning of that? No.
No.
Suppose if my name is Prerna. Suppose if someone name is Prerna means inspiration, and suppose that guy usually motivates most of the people. So it means his name and his working, they are resembling each other, na? His name is inspiration, and he is also inspiring many people. So it is matching now, work and name.
Mm-hmm.
Are you getting what I'm saying?
Mm-hmm.
Mm-hmm. It
Yeah.
means you are not sure.
I got it.
Okay. Suppose your name is Vishnu.
I'm
And,
saving.
and you're also the avatar of Vishnu. Suppose Chakra.
I'm,
Okay.
okay.
Suppose, but actually you are not. I know that. Okay, so this is the enthalpy of formation, right? So if it has a name of combustion, so obviously combustion is taking place. If I say enthalpy of formation, so what does it mean? When anything is going to form. Okay, suppose if I'm talking about the calcium carbonate, so when you have oxide, which you can say quicklime, and if it is combining with the carbon dioxide, so it will form CaCO3, calcium carbonate, and it has a delta HF formation. Okay, delta HF. So formation of delta H, we can say minus 178.3 kilojoule per mole, kilojoule per mole. Okay, so what is the enthalpy of formation? So we can say it is the heat change when 1 mole of substance is formed from its constituent. So this calcium carbonate is getting formed from the CaO and CO2 na. So obviously heat will change, because after the process definitely heat will change. So it is the heat change, it is the heat change when 1 mole of, when 1 mole of substance, when 1 mole of substance is formed, when 1 mole of substance is formed from its constituent, from its constituents. Constituent means these are the constituent. You are made up of so many cells, right? So it is your constituents. So when anything is getting formed from the constituent, so this is your delta HF formation. Are you there or not, Vishnu?
I'm here.
Okay, okay. You are not responding na, and you are not showing your video as well.
Okay.
So enthalpy of formation means it is the heat change when 1 mole of substance is formed. This is your 1 mole calcium carbonate from the constituent. So they are coming from the constituent. So delta HF formation is, it is, that will be given to you. Don't worry. You don't have to calculate. Okay, that will be given to you. Fine. So you, obviously, if I ask you, can you define what is the enthalpy of neutralization? Obviously, you can guess it.
When everything's neutralized in substance, when
Which
the
means,
when the substance are neutralized, I guess.
yeah, when the substance neutralization, neutralization. But what is enthalpy of neutralization?
It's the heat change when one
Yes,
mole of
yes,
substance is
yes.
neutralized from its constituent.
Very good, very right. So we can say it is the heat change. It is the heat change usually evolved because they are combining. Okay, so when, but remember we usually take the standard condition. Okay, so when an acid standard condition like 1 gram, like 1 mole, when an acid combines with a base, with a base, so we can say HCl plus NaOH, it will give you what? NaCl plus H2. So it is a neutralization reaction. So delta H, you will call it as a neutralized. So that neutralization is 57.1 kilojoule. So this is what? So kilojoule per mole we usually say, or like whatever you have taken. So itni amount of energy is coming. So that is your enthalpy of the neutralization, right? So same thing, we have so many type of enthalpies. Like if you are breaking the methane gas, like if you have completely broken the methane, see Vishnu, if you have a CH4, okay, that is your methane, but now you have broken this, completely broke all these substances are coming like this, कार्बन अपना अलग निकल गया, चार हाइड्रोजन अलग निकल गए. So you will call it as a enthalpy of atomization. Okay, so what is the meaning of atomization? When you are breaking everything, when you are breaking all the bonds.
Can you
So
give me
when
one
the,
second, please? Hold on, give me 1 second.
yeah, yeah, sure,
I
sure.
just need a bit to get everything down.
Yes, so enthalpy of neutralization. So when you have the methane and you are breaking everything, like from the methane, carbon and hydrogen we have. So when you are separating the carbon and when you are separating all the hydrogen, it is completely broken. Okay, suppose if there is a someone and you are breaking everything, like you are breaking his hand, you are breaking his leg, you are breaking his neck, everything, you just broke that person. So it do you I'm just taking that example, don't worry. So it is just the atomization. So in a compound, when you are breaking everything, all the atom you have just separated, so you will call it as a enthalpy of atomization, right? Fine.
Hmm. It is the
Okay.
heat change when everything in the substance is broken,
When
right?
one mole of substance is dissociating, like
Okay.
that methane can be gaseous form, can be anything. And so when you are just separating carbon and all the hydrogen separated, okay, so this is separated means you can say dissociation. When two people are going away from each other, so it means you can say they are getting dissociated. Okay, so it is the heat change when the one mole of substance dissociating into the other atoms, like separated atoms. Fine.
Completely dissociated, right?
Yeah, dissociation you can say. So there's a
Completely.
yeah, completely. Enthalpy of atomization. So it is always the enthalpy change. If I ask you ionization enthalpy means like the amount of energy required to remove the outermost electron. Like if I say I have the sodium, so
Yes, sir.
sodium has a 2 8 1, right? It has a outermost electron in the third shell because sodium is 11 atomic number, na? So 2 in
Yeah.
the first shell, 8 in the second shell, and last in the third shell. You know
Oh, are
this,
we
na?
doing electron configurations?
Yes, yes, yes. So it is the electronic configuration. So sodium also want to lose this electron. Why? After losing this one electron, it will gain the noble gas configuration. Na?
Yeah.
Every atom want noble gas configuration, so it want to lose. So that's why when you are going to take that electron, so you don't have to spend very much. Okay, so you will give very small energy and you can just take out this electron, but some amount of energy you have to spend. So that is called the ionization enthalpy or enthalpy of ionization. So HCl is there. So suppose if you want to remove that, so if you want to remove that, so it means H, you want to remove the electron from the H, it will become H plus and it will become Cl minus. So it means you have taken out the one electron from the hydrogen. So that is the heat change when one mole of covalent compound undergoes into dissociation, or you have just taken outside. So it is the ionization. Electrons are, see here, I haven't taken out any electron. There is a like equal participation, like carbon has taken its electron, hydrogen have taken its electron, so it is carbon and hydrogen. But here hydrogen has loosened its electron and chlorine has gained the electron. So it is the enthalpy of ionization. So I guess it is very easy, whatever the process is going to happen, so obviously the name you can give automatically, if it is sublimation or if it is like boiling, melting, okay, anything, any energy it can be, any kind of enthalpy it can has. Okay, so now what type of question we usually see, if I am saying, if I am giving you certain conditions, so by using the condition, can you identify the enthalpy for the main reaction?
Yeah.
Usually questions arise from that part, and that law is given by the Hess's law. So in the thermodynamic, Hess's law has a like very good importance. So Hess's law we are going to discuss. Hess's law, what is that Hess's law? So see, Vishnu, if I talk about this Hess's law, so it is the total heat change in any reaction. Okay, so
Wait,
it, yeah.
I'm gonna write this down.
Okay, okay. No. I will tell you. Don't worry. I mean, I will write down. So I will write down. So don't worry at all. Okay. So in the Hess's law, I can write there the total heat change. I will explain to you as well. Don't worry. It is nothing. The total heat change in a in any reaction. remains the same, remains the same, whether the reaction is taking place. It is like just tell me, suppose this is your home, okay Vishnu, and suppose this is my home. This is your home, this is my home. Suppose if you are coming by your personal jet, okay, but if you are coming by your personal jet now, so it is taking a lot of maintenance, lot of petrol, lot of many things, okay. So the total cost is around suppose $1,000, okay, okay, total cost for coming to my home. But now you are thinking, no, 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 I should not use the my personal jet. You are coming by a car. So you are going first this A point, then you are going this point B, and then you are going to the my home. So just tell me when you are coming by the home. So now you are directly coming, or you are coming like after taking so many breaks.
Yeah.
I'm asking.
Yeah, no, you're right.
Okay,
Breaks.
so whatever the amount you just spent by the personal jet, so obviously same amount will be spent here by the car as well. Okay, it is not the difference. So
No.
Hess's law is also saying that whatever you can follow anything, you can come directly, you can come indirectly, but the amount, but the energy spent will remain the same. Okay, so the total heat change in any reaction remains the same, whether the reaction is taking place in a one step or whether it is taking place in a number of step, because ultimately you have to reach there only. So the reaction, whether the reaction take place takes place whether the reaction takes place in one step or in a number of steps, in a number of steps, तो चाहे तो वो एक में हो चाहे वो बहुत सारे स्टेप में हो, whether it is taking in a single step or so many step, but the energy will remain the same. Okay Vishnu, suppose I'm saying C plus O2 CO2. So the delta HF formation, it is equal to minus 393.5 kilojoule per mole. Okay, that is the energy enthalpy change for the formation of CO2. But suppose, so this is the overall reaction, but suppose this reaction is taking place in a stepwise, like one by one. Firstly carbon was in the solid state, right now it is in the gaseous, like it is the solid and it was the gaseous. So I directly got the CO2 which is in gaseous state. So it means if you see, firstly I had the carbon and it is combining with half of the O2 gas. So firstly it forms CO first. Okay, firstly it forms CO. So we have the enthalpy for this minus 100.5 kilojoule per mole. Okay, now once your CO2 is formed, so CO2 is combining with the rest of the oxygen, because for the formation of CO2 you need two oxygen. So now it is combining with the other oxygen and finally it forms CO2. So now it is the next enthalpy change for this step, minus 283.0 kilojoule per mole. So now you can see the first step is a complete reaction for the C plus O2 CO2, but in the second reaction it is taking place in two step. But you got from C carbon to CO2, yes or no?
Hmm.
So first step is taking this energy and second step is taking this energy. So how will you find out the C plus O2? Obviously you have to add this or you have to subtract this. Obviously you have to add this. So just tell me, because C plus O2 O2. So C plus O2 it will form the CO2 na? Cs plus ka O2 it is going to form CO2. When you subtract them, why? Because when you subtract them to CO cancel out and you will get C plus half O2 it will become O2. So it means when you add both these energy, just add karna Vishnu. So when you will add, so you will get the same amount as you had for the above reaction. Are you getting? एक
Mm-hmm.
रिएक्शन हुई स्टेप में, दिस रिएक्शन इज टेकिंग प्लेस इन अ स्टेप. So when you add them, so obviously you will get overall reaction this, and you are getting the same value as you had already here. So these two energy are same or not?
Yeah.
So what it is representing? It is representing that whether your reaction is taking place directly or if it is taking place in a stepwise manner. So the total heat energy will remain the same. Okay.
Yeah.
Suppose you are going to your school directly. So energy spent was thousand. But suppose in the next time you are going like from your home to one friend to another friend, and then another friend to complete your school. So it is a stepwise, na? So even if you're going stepwise, the total amount or the energy will remain the same. Okay, Vishnu? It is
Mm-hmm.
actually said by the Hess's law. Fine.
Yeah.
So Vishnu, just tell me, this reaction is a complete reaction or it is taking place in a stepwise manner? This is.
That's a complete reaction, I think.
Yes, yes. And these two are complete or
Stepwise.
stepwise. So we just make this stepwise as a total, na? देखो C plus O2 and half O2, CO cancel, because product and reactant can cancel by another one. So we get overall like this by adding. So if we have add these two reaction one and two, we got this overall reaction like this. So obviously we have to add the enthalpy as well, na? That's why we just add them, 110 and 283. I got 393. Okay. Okay.
Yeah.
So now Vishnu, now suppose if I am giving to a question and you have to apply your logic, and you have to apply your logic like by how you will get the total. Suppose I have 6C plus 3H2, and we are getting C6H6. Okay, but I don't know the enthalpy change. I don't know the enthalpy change, but our reactions are given to you. Some reactions are given to you, and on the basis of that you can easily determine what you have to do. Okay, this is liquid, this is a gas. You have to think. So you have to find out enthalpy by using all these steps. So by using steps you can, I guess, find out how to solve.
Okay, what the heck? Mm.
It is forming. Reaction can be reversed in these steps, so you can also reverse that. They are maybe they are giving you just to confuse you. This is the reaction number one, and this is a first step, and the enthalpy change is given to you, kilojoule per mole.
Wait, so I have to figure out like if it's combustion
No,
formation.
no. By using these steps, you have to find out the total above reaction enthalpy. See.
Oh.
In the above reaction, if I haven't given you this thing, if I'm not giving you this thing, so by just adding, you can find out the enthalpy, na? By just
Wait.
adding. So that is the answer. So same thing, you have to apply your logic like by these steps. By using all these steps, you have to find out the enthalpy of above reaction.
Okay.
You have to apply the like permutation and combination.
Well, what?
In the mathematics, have you studied the permutation and combination?
Yeah, but why is that relevant here?
Relevant means permutation and combination is just the, like not the term for calculation. It is for the like the ways you have to find out. Okay. Permutation and combination means like whenever you have to try the ways, different ways, तरीके, अलग अलग तरीके, different ways to solve the answer.
Can you like show me an example how to do it?
Okay, by doing this, na? Okay, I will. But at least try your logic. At least try your logic.
Wait,
At
I need what's the three equations? I need to add them and find out the total delta H for the top equation.
in the yes, in these steps, I have already given you small steps, okay, and different enthalpies you have. So you have reaction number 1, you have reaction number 2, you have reaction number 3, and now all by using all these three reaction you have to find out the enthalpy of this. So just think how many things you just need. Just tell me. We have this 6C, okay? Just tell me in the reactant side which have the C. Just tell me. In the
Just
in this overall reaction, can you just see 6C?
okay for
And
one and two
this 6C is in reactant side or product side? Firstly, tell me.
reactants, so it's one and two.
So, अरे एक second. What is 1 and 2?
Equations one and two have
Why are you saying reaction 1? Why
or
reaction 1?
equation one. Yeah, equation one.
Why are you saying equation 1? Equation 1 is not needed.
Okay, then
See,
two because I see
Vishnu,
alone.
एक second. This is 6C, right?
Yeah,
Forget about this 6 now. Just see the C. Okay. So in the reactants, I have carbon. So just see in all these reaction which have the carbon. Can we
two,
say yes? So reactant 2 has the carbon. Fine. Okay. How but it is multiplying by which number?
six.
So it means I have to multiply by 6 to second equation, right?
Sure.
For getting 6C. So right here, multiply by 6 into the equation number second. Am I right?
Yeah.
Okay. Now see the next step. It is addition, and it is 3H2. Just see where you can see H2 in the reactant.
Three.
3. Okay, and you have to multiply by which number?
Three.
Yes, and it is addition or subtraction or multiply divide.
Addition.
Yes, addition, because you can see this sign. Addition it is. So you are saying now 3 into equation number 3. You don't have to see anything. Just see your main reaction and do it. Okay.
Oh, okay.
Okay. So it is done. These two step.
Yeah.
Now come to the product side. So in the product side, what you can see C6H6, right?
Yeah.
C6H6. So if it is C6H6, it is the product side. Remember. So can you see any C6H6 in the product side? Can you see
Yeah.
C6H6 in the product side?
No.
So it is not in the product side. So, but can you see C6H6 in the reactant side?
Yeah.
Oh, so it is at the product side. So it means what you have to do? So you
Subtract.
have to take minus
Yeah.
because it is opposite. If it
Yeah.
is in product, then it is more fine, but it is in the so you have to say, yeah, see, it is C6 and it is C6. So you have to multiply by any number or not?
No.
No. So what I have to write? Just,
Equation one.
yeah, just equation 1. That's it. Just by doing this, you will find out delta H. So now put up the values which is given to you in the equation. Can you just see these delta H?
Oh, wait, that's it?
Yeah, just it is 6
Oh,
into, write the second equation enthalpy. What is the second equation enthalpy? It is, just write these,
negative.
yes, negative of 393.5
Oh,
plus
that's so
3
easy.
into, yeah, 3 into, now write the equation number third enthalpy, minus
280.
285.83. Now minus, what is the equation number 1 enthalpy?
So you have to do plus. You have to do plus. All right, but
Yeah, it will become minus minus plus. Yes. Okay. So just by solving it, you will get the enthalpy. And that enthalpy is basically for the total, na? I told
yeah.
you Hess's law. Enthalpy will remain the same whether you are writing complete reaction or you are writing in a stepwise. But the total will remain the same. Are you getting?
Mhm. Yeah.
Okay. Suppose if I'm saying but do you know how to analyze this situation? Okay. Suppose if I say this is A and this is B, okay. I am saying what is the cost of going from A to B? What is the cost? So and in the question it is saying that A to C cost, it is 5 rupees. C to D cost, it is 5 rupees again. D to E cost, it is 15 rupees. E to B cost, it is 20 rupees. So just tell me what is the total cost from A to B. Can you find out
Hmm.
how much cost it is? How much cost it is?
Mm-hmm.
Array 5 plus 5 plus 15 plus 20. Vishnu, what are you
35.
doing? Yes, it is 35. So you just by using the step, you just find out the total cost now 35.
Yeah.
Isn't it easy?
Yeah, pretty much.
Okay. So remember always whenever these things are given to you, so I guess you can easily solve such type of questions. Got it?
Mm-hmm.
Enthalpy change. Okay, so this is how we can just solve many questions. Okay, now suppose if I am giving you a one more question and you have to try that. This is the enthalpy change we can just find out. Now suppose if I am saying you have a rhombic sulfur. This is
What's
a
that?
rhombic. It is a like different shape. Okay, different.
Oh,
We have so many type of solid like rhombic solid, monoclinic solid. Okay, you will study. Don't worry. So rhombic means sulfur and it is O2. So rhombic and O2 when they are combining, so it will give you what? It will
sulfuric
give you
acid.
the SO2 gas, na?
Oh, never mind.
So rhombic sulfur is combining with the O2 which is in gaseous state and it is forming SO2 which is a gaseous state. So the delta H is given to you minus 297.5 kilojoule per mole.
Oh, it's the other way now. God damn it.
Now if I am giving you sulfur monoclinic sulfur, it is a monoclinic and it is also combining with the oxygen and they are forming SO2 in the gaseous state as well. They are also giving SO2 and the delta H is given to you minus 300 kilojoule per mole. Okay. So now Vishnu, you have to find out the delta H for the rhombic sulfur to monoclinic sulfur. So you have to find the enthalpy for monoclinic to the rhombic to the monoclinic sulfur. तो अगर आपके पास rhombic है आपको monoclinic बनाना है तो उसके लिए कितना लगेगा?
Oh, wait,
From
so
from rhombic to mono.
you can cancel them out, right?
You have
You
to
can
guess it. From
you have to
rhombic you have to find out the monoclinic. Just imagine and you have to do this. Just think maybe.
you can cancel out O2 and O2, right?
The equation number one minus equation number two. You are saying that
Yeah.
because see, from rhombic sulfur we are finding out the monoclinic sulfur, right? So
Yeah.
firstly we have to see the reactant, right? So rhombic is in reactant. So which reaction has a rhombic in reactant side? One or two? One.
One.
Okay, so we will write equation number one first. Okay. Now, but if this monoclinic is in product,
No,
is
it's
there
in
is the it is
reactants.
are it is in product na in the main reaction.
Wait,
In
what?
in the question itself, I have given to you rhombic to monoclinic. So it is in product
Okay.
na. In the main reaction, it is in product na.
Sure.
Vishnu, it is my question. It is my question. So obviously you have to go according to question only na. Obviously it is
Yeah.
product. Rhombic sulfur to monoclinic you have to form. So monoclinic should be in react product and rhombic should be in reactant. So now,
Yeah, that's what I said.
so monoclinic sulfur can you see in the product side in the step by step reactions?
No.
But can you see monoclinic in the reactant side?
Yeah.
In which equation?
Two.
2. So it means I have to use minus sign or plus sign?
Minus, right?
Minus, yes, minus sign because it is not in product. So equation number 2, right?
Wait, isn't that what I said before?
If you said the same, then it's very right.
Okay.
If it is same, then it's fine.
But I think I
Okay.
said it for a different reason though, but never mind.
Okay, fine. So what is the value of equation number 1? Just tell me.
Negative 297.5.
Okay. And do I need to do something else too, like equation minus equation 2 or something else, or just fine?
I mean, I don't think so.
Yeah, because it is very simple question.
Yeah,
They didn't ask anything else. It is very simple, rhombic to monoclinic. So just
it's just yeah, it's just
it's
that.
very basic. Okay, and minus 300. So after
I'm I'm
solving,
I'm pretty new to this, so I'm not really sure. Like I'm still pretty new to this.
okay. So just when you just calculate that, so you will get the answer, isn't it?
Okay. Yeah,
Fine.
so it's gonna be like 3 point something, 3 point like 2.5
Yes.
probably.
Okay. So this these type of question, I guess you can solve it. Of course, we will do the numerical practice as well. Okay. So now Vishnu, actually we have another topic which is called the bond energy. So whenever they ask you what do you mean by the bond energy, so always remember bond energy is the like all the bond, like you have to write the bond enthalpy or bond energy of all the reactants minus all the energy of the bond energy of the product. This is how bond energy is like product. So bond energy is what the average energy required to break or dissociate 1 mole of bond present between the atoms in the gaseous state. What does it mean? See. If I am saying I have given a reaction, okay? Suppose if bond energy is given to you like Cl bond energy, Cl को Cl2 के लिए bond energy is given to you 243. If bond energy is given to you hydrogen it is given to you 435. And if HCl bond energy for the HCl, if it is given to you 431. Okay, so different bond energies are given to you. Fine. So if different energies are
Oh,
given
this
to you,
is
this is the bond energy.
they're all diatomic. They're
Yeah,
all
yeah,
diatomics, right?
yeah. So now you have to find out the bond energy for the HCl now. For the HCl. It means delta H you have to find out for the HCl. And these things are given to you. So how
Isn't it
can you find out?
431? Isn't it 431?
431. How?
Yeah.
See Vishnu.
H2Cl is
Vishnu, this is the different thing. This is a different concept. Reactant minus product you have to do. Delta H you have to find out for the HCl. So see what you have to do. How we will form the HCl? Obviously, we usually say na, like when H2 is combining with the Cl2, then it form the 2 moles of HCl, yes or no?
yeah.
H2 plus Cl2, it form 2 HCl. So H2 means
Oh,
what? Can I say HH?
435 plus 243.
Yeah, just one second, just
Right.
see. Chlorine means can I say Cl bond Cl? And can I say 2 into में H bond Cl? Can we say that? Vishnu, tell me. H2 means
Yeah.
HH bond, Cl2 means Cl bond, and HCl means HCl bond that you can see.
862, right?
So now how will you find out the delta H? So you can see delta H can be find out bond enthalpy of reactant minus bond enthalpy of product. So what is the total
Oh,
bond enthalpy of reactant? Can we say? What
yeah,
does it mean? So what is the
it's
HH energy?
678, right?
Now what is the HH bond enthalpy? Tell me.
435, so it's 678.
435 plus and what is the ClCl?
435.
435? ClCl
Oh,
243.
243. Yeah, 243.
243, right? So all reactants are done.
678, yeah.
Okay. I said minus. Okay,
Yeah,
minus.
minus
And then product. Product is how many? Two or one?
831. 2,
How
it's 830.
many?
It's negative 157.
So can I say 2 because it is 2 HCl? So 2
Yeah,
into HCl bond is how much? HCl.
435.
Yes, 31
31, yeah.
HCl. It is HCl.
Yeah, yeah. I
And just
misspoke.
close it. So you will get the enthalpy for the. Did you understand that? So
Yeah, yeah, I did.
whenever bonds you have to find out, so obviously you have to write the reaction and bonds are given to you. So HH, HCl, Cl, and you will get the answer. So your answer will be minus 184 kilojoule.
184. Yeah.
Kilojoule. Fine, everybody. Okay,
Yes.
but Vishnu, this
Yes.
minus 184 is the formation of 2HCl. This energy is basically for the 2HCl, but I want the enthalpy of only 1HCl.
Divided by 2, I guess.
Yes, because it is basically this formation is for 2HCl, na? Because the
Divided by
reaction.
2.
So if I want to find out for the 1HCl, then you have to divide by 2. Because in the question they were asking for the 1, not for the 2. So
97
9.
form. Wait,
Oh, sorry,
no, it's
92,
97.
92,
92, yeah.
92 kilojoule per mole. Got it?
Yeah.
So this is how we can quickly find out the bond enthalpy. Any doubt here?
No.
Okay. So Vishnu, actually we are moving just the small, I mean, yes, we have done the first law, zeroth law. So here we have the second law of thermodynamics.
Right.
So second law of thermodynamics. So Vishnu, just tell me, whenever anything happen, like whenever any gas is there, so gas usually expand automatically, na? Suppose if there is a bomb blast, if there is a bomb blast in any country, so obviously when there is a bomb blast, so whatever the dhua is coming, the smoke, so it is going to be spreading or it is just limiting to a particular place. It is spread or it is limited to a particular region.
Spread.
Yes, everything usually is spread, na? Because
Just
gases has the
even.
tendency. Okay, so it means all, it is known as a degree of randomness. Gas has the tendency to flow. Gas actually want to flow from one side to another, and it is automatically. If gas is automatically going from anywhere, so it is done by you or it is automatically taking place.
Done by automatically.
Yeah, it is actually taking place automatically. So remember always, entropy randomness. Just Vishnu, tell me one thing. Everyone want to be free, or everyone want to be just remain attached close together with everyone.
Be free.
Yes, everything want to be free, everything just want to be free, very okay. So that freedom, that randomness, that free thing, it is known as a entropy. Okay, so the entropy of the universe, what do you think? That the entropy, the randomness of the universe, what do you think? It is contracting or it is expanding?
Expanding.
So can we say so? And the process which take place by itself, जो अपने आप हो जाते हैं. Like suppose if a stone is coming downward, so if this stone is coming downward from the mountain, so can it go back
No.
automatically? No.
No.
So it means, so all those process which take place by itself, it is known as a spontaneous process. So what do you think? Spontaneous process are reversible or irreversible?
Irreversible.
Yes. If a river is flowing from north to east, so can
What?
it also, suppose if a river is coming from north to east, suppose, so can it go back east to north?
No.
No, because mountains are here only. So from the mountains it is going to plains. So can river go back from plains to mountain?
I don't think so.
Obviously no, no. So all natural spontaneous processes are reversible or irreversible,
Irreversible.
because they are taking place by itself. But if you
Yeah.
want to take that river to the mountain, then you have to put a motor to take that. A
Or a
driving
pump.
force you have to give, yeah, pump. You have to put that, right? But that it will not be spontaneous. Spontaneous means which take place by itself, right? Which is taking place automatically. So they are thermodynamically reversible or irreversible?
Irreversible.
Yes. So they are thermodynamically irreversible. Irreversible. The entropy, if I say, so the entropy of universe increasing or decreasing. Entropy means randomness, freedom. So entropy of the universe is increasing or decreasing?
Decreasing.
Eh? Abhi to you
Increasing.
said only, like
Oh,
we want
increasing.
freedom, we want randomness.
Increasing, I guess.
Yes, increasing. Okay. So
Yeah.
remember always, like for the spontaneous process. So this is what this is. What is the meaning of spontaneous? If I just ask you,
On the spot.
those processes which take place by itself,
Okay.
by naturally. Okay. Suppose if you have a ice and there is a lot of summer, a lot of heat, so that ice automatically melt, or you have to try to do something. If you have a piece of ice, so it will automatically melt, or you have to do something for its melting.
I can just leave it outside.
Hello, now can you hear?
Yeah, I can just leave it outside. Like I don't have to do anything to like.
Yeah, you don't have to do anything, it will melt automatically, right?
Yeah.
So it is spontaneous or non-spontaneous?
Spontaneous.
Yes, because it is taking place by itself. So it is irreversible. Okay. So an entropy is completely increasing for the universe. So all and remember always, whenever you have any spontaneous process, so mostly time entropy increases. Okay. So for most of these spontaneous reactions which take place by itself, so entropy always increases. Fine.
Yeah.
This is the
Yeah.
second law. So entropy means randomness, freedom. So her natural process का spontaneous का take place by itself. Fine, everybody. Okay, Vishnu, it's all for the today. Any doubt? Okay. So Gibbs free energy is left. Okay, we will discuss the numerical. Are you getting this chapter, Vishnu?
Yeah.
Okay. Any doubt do you have?
Nope.
Okay, okay. Then see you. We'll meet you in the next class. Okay.
Mm.
Bye bye.
Bye.